Okay, let's take a look at our next one here. So we're starting off, we have a nitrile group there. We have a Grignard reagent here in the first step. Grignards will react with nitriles. They go to make ketones. So the Grignard attacks, kicks the electrons up onto the oxygen. I mean nitrogen, sorry, up on the nitrogen. I'm not going to go through that full mechanism. So after we kick the electrons up on the nitrogen, we add in the acid, that protonates the nitrogen, then the water attacks, and so you eventually get to the ketone. So we're putting a phenyl group on, and that carbon of the nitrile still has its phenyl group on, and it's that carbon of the nitrile that makes the ketone. So it's, I'll highlight it here. It's this carbon becomes the carbonyl carbon. So it still has its phenyl, and we've added the phenyl from the Grignard, or whatever the Grignard adds, it makes the ketone. So nitriles and Grignards will make ketones. We covered that in chapter 16. Third step, we're reacting with a Wittig reagent. I'm not going to go through this mechanism because I just did that a moment ago. We had another Wittig reaction on the exam, but it's the ylide reacts as a nucleophile, and we attack the carbonyl, kick the electrons up onto the oxygen, and then the oxygen adds to the phosphorus to make the little four-membered ring. And so in this one here, our final product, we get the alkene. The alkene that we get. So we're putting this here goes on in the place of the oxygen. That carbon takes the place of the oxygen in the Wittig reaction. There's the alkene that you get. Questions on that?
Do we need to know the mechanism for forming the ketone nitrile in the Grignard reagent?
No, I told you I would not ask that one. We did a couple different reactions with nitriles, and they were all very, very lengthy. Okay. And so we did the Grignard with the nitrile. We also did the hydrolysis of a nitrile, and I told you I wouldn't ask either one of those because they're just so lengthy. And
what about the one where you reduce it with L-A-H and you form that amine?
No, I told you I wouldn't ask that one either. I forgot about that one. So I also said that I would not ask that one. It's also very lengthy. You know, I got to have on the exam, you know, you've only got 50 minutes in there, so I usually give you, I start you a little early and let you go over a little bit. And so I try to get you close to an hour. But still, an hour on that exam, I can't do too long of a mechanism. It takes up too much time. So any mechanism I'll ask would be, you know, one of the shorter ones. Okay, our next one here, we have DIBAL-H there in the second step, followed by water in the second step. DIBAL-H there in the first step. So these two are going together. This will reduce that nitrile to an aldehyde and stop at the aldehyde stage. So after the second step, you get the aldehyde. That's, like I said, that's not a mechanism that I will ask on the exam, and I'm not going to go through that. It's so lengthy. So it's just that you're attacking the nitrile with the hydride, kick the electrons up, then we add the water, we protonate, and then the water adds, you get the oxygen adds, and that's where that oxygen comes from. So we stopped at the aldehyde stage. Second step, we're reacting with a secondary amine. We got acid in there as a catalyst. That acid is going to protonate carbonyl. So let me just go ahead and put that on there. So the acid here protonates the carbonyl, and that makes it more susceptible to nucleophilic attack. And then the nitrogen attacks and kicks the electrons up. Now, that oxygen is going to reach over and grab the hydrogen off the nitrogen so that we have a water molecule that's a good leaving group. Now, the lone pair on the nitrogen will kick in to form a double bond and kick the water molecule off. So we first get a double bond with the nitrogen. But we want to get rid of that charge. So you're going to take the water molecule and reach in and grab the hydrogen here. Electrons kick in to form a double bond and kick the electrons back up onto the nitrogen. So we make the enamine. Amine as our product. And I made a mistake there on the answer key, didn't I?
Yes.
Yep, I left a carbon off. So when I made my enamine, I put the double bond in the wrong place because I was missing a carbon. So I apologize for that. This is the correct answer. Now, when we make that enamine, you will have a mixture of E and Z here in this case, because on the double bond there you can have E and Z. And I've got the E drawn. The E will always be the major because you've got less stereos. So the E here is the major. You can see your top priorities. Here is top priority, here's the second priority, and up here you have the hydrogen, and the nitrogen is top priority, and the hydrogen is second priority. So my top priorities on opposite sides, that's the E. So we will get the E as the major. Okay, so on the answer key you have incorrect. I left a carbon off. So that put my double bond in the wrong place since I was missing a carbon on that answer key. Any questions on that? So secondary amines give the enamine, primary amines give the imine with an I. Secondary amines give the enamine with an E. Our next one, we have an oxidation. we have a strong oxidant. The silver oxide is an oxidant. We have the sodium hydroxide in there with it. So the silver oxide and sodium hydroxide is a strong oxidant, the combo there. We're going to oxidize that aldehyde, and this gets oxidized to a carboxylate ion. Now you can't have the carboxylic acid if you're in a basic solution. We are in a basic solution, so it stops there at the carboxylate ion. If I want the carboxylic acid, I would have to acidify in a separate step. So there's what we've got if this is all we've got in there, but we could, you could do it in a separate step, add acid, and then that will go ahead and protonate. But if you don't have acid in the second step, then you have to stop there at the carboxylate salt. Sodium will balance the charge out if you want to show that. You don't have to. Okay, questions on that? Our last reaction here we've got acid and water. And water, that starting material there is. If you look at the starting material, if you pay close attention to it, that is an acetal. This carbon right here that I'm highlighting, it's got an O-R group, and up here at the top, it's got an O-R group. It's got two O-R groups attached to the same carbon, the carbon that I'm highlighting there in blue. That's an acetal. So, acid water removes the acetal groups, and we get a carbonyl back. So, acid and water, you're going to protonate one of those oxygens. I'll just show it real quick here. Take the water then, break this apart. We have an extra hydrogen there on an oxygen. It doesn't care which of the oxygen it's on, so part of the time it's going to jump over here to the other oxygen. That will make that a good leaving group. We'll take this OH, kick in to form a carbonyl, and kick off our leaving group. Now, all we have to do is get rid of the extra hydrogen there on the oxygen. You can use water to do that. We do have water in the reaction. That will pull off the extra proton, and that gives us our product. We get that carbonyl back. Your acetals are always made from a carbonyl. So that acetal carbon becomes a carbonyl. Blue carbon becomes the carbonyl carbon. I'll just go ahead and put it in blue. There it is. And the other two oxygens, the two oxygens that were already on there, those become OH groups. Because we made the acetal from two alcohols and a carbonyl. Questions? So let's take a look at some synthesis questions. for the reagents to do these conversions. So let's see what we have here. What reagents will accomplish this conversion? If you notice what we have an alkyl halide there to start with. Let's see, that's a primary alkyl halide. Don't know if that helps me or not. Let's see what I got over here in the product. If you notice what we have in the product, we've made an alkene. If you think back of ways that we made alkenes, well, we only talked about one way to make an alkene. That was the Wittig reaction. So that's what this is. We had to use a Wittig reaction to make this. So you can work your way through forward, or maybe it might be easier to go here and work your way backwards. We did talk about a retro Wittig reactions. We did go backwards on those Wittigs. So on those, I told you to cleave the double bond. You make one side the carbonyl, make the other side the ylide. So let's just go backwards here. Let's make this side the carbonyl, and we're going to make this side the ylide. Ylide, we just put a triphenylphosphonium group on there, negative charge. There's the ylide. So that ylide and that ketone will give that product. Now if you take the alkyl halide, we know how to make the ylide from an alkyl halide. First of all, we reacted with triphenylphosphine. That gets us that group. So triphenylphosphine would attack, do SN2 to kick off the bromine. That's just an SN2 reaction. And then to get a hydrogen off, there's two hydrogens right there right now. You need to pull one of those off so that you will have a negative charge. All you need is any strong base. You could do sodium hydroxide, that would be fine. And the base will pull that off, hydrogen off, and give you the ylide. So first step, we react with triphenylphosphine. Second step, any strong base. Third step, we'll react with this ketone, and that gets us to that alkene. That's the only way we talked about here in these two chapters. To make an alkene was using a Wittig reaction. Questions? Okay, let's take a look at our next one here. Let's see what's happened. What's changed? Let's see, all that side stayed the same. Here we've got alcohol that's went to an imine. Got an imine there. But the imines we made from aldehydes and ketones. We made an imine from an aldehyde or a ketone. So I've got to get that alcohol to an aldehyde or ketone or something before I can even think about making an imine. Now, if I get this to an aldehyde, then I've got an aldehyde and a ketone, and both of those can react and make imines. So let's protect the ketone first, and then I don't have to worry about anything. let's put a protecting group on that ketone. So that's the first thing I'm going to do. The first thing, I'll just react with our diol acid, and that puts a protecting group on. That makes the cyclic acetal. And now I don't have to worry about anything. Now we're going to take our alcohol, and notice that my imine, this carbon had a hydrogen, so this is that carbon right here. So we want to keep the hydrogen. So we want to make that into an aldehyde. So that is either PCC, that's our second step, PCC, or you could do SWRM. That converts that primary alcohol into an aldehyde. Then we can react with ammonia. We'll use acid as a catalyst. That will be step 3. That will get us the imine. So that gets the imine part. But then I want my protecting group off. I want the carbonyl back. So 4th step, we'll just react with acid and water. That takes the protecting group off. So the ammonia will make the imine, and the acid and water, you need the water, acid and water will take the protecting group off, and you get the ketone back. So that's the best way to do it. Protect it, oxidize to make the aldehyde, and then react with ammonia to make the imine, and then take the protecting group off. Questions on that? So the last one, there was a mistake on the old exam. There was I don't know what I was trying to do there. Either I was missing a carbon or something. So let's write this as our question. This is not what was written down on the old exam. I remember now that I had a mistake that year. So let's write this as a product. Okay, so let's see how we can accomplish this. Take that starting material to this product. Still have started with a ketone. I still have a ketone, but you notice my ester's gone, and we've broken the ring apart. So at some point I've done some kind of a reduction there, but I've left the ketone alone. So first thing we need to do is protect that ketone. If I've still got a ketone there, I need to protect it here so we keep it all the way through. So we're going to react here in the first step. We'll react with the diol. Acid as a catalyst. That will make the cyclic acetal. That gives us the cyclic acetal. And then we can see what we're going to do here. Reduce let's reduce this. Let's reduce it with no, that don't work either. That's not what I want. That's what I wrote down on your answer key. I can't remember what I was trying to accomplish there. if I do lithium aluminum hydride, that would leave me another alcohol. Here, let's do this. 1, 2, let's do this alcohol. That'll work. Okay, now let's make this one here. That's symmetrical. So on the old test, there's missing a carbon right there. Let's do this. So now if we react with lithium aluminum hydride in a second step, that will reduce that ester. We'll be left with the negative charges. So we need to acidify those to get the alcohol. So we can use acid, but we also want to take off our protecting group, so acid water will do that. That removes the protecting group, we get the ketone back, and that protonates the two oxygens and gets us alcohols. Okay, so that's what I should have had there on that old exam. I'm missing a carbon on that old exam. That's the problem. Yep. That's what I'm doing. Yep. Okay. Questions? Now I did notice on this old exam some reactions that was not on there. So be careful. Anything we talked about is still fair game. I didn't see any decarboxylations on there. So probably that year I was in a different spot. I think that year I hadn't got to that. That was the last section in chapter 17. And the way the semester worked out that year, I think I'm pretty certain that I didn't get that covered for this exam. So the decarboxylation was the beta keto acids. If you have acid, water, and heat, then you eliminate CO2 out of any beta keto acid. So don't forget those. So I did notice that was one reaction that was not on that old exam. There's probably more. We talked about, I didn't see any, I noticed I didn't have any anhydrides, and we covered anhydrides. I didn't see any anhydrides on there. So we had ways to make anhydrides. We had reactions anhydrides underwent. And I didn't see one of those on the old exam. And we did cover all that. We covered acyl chlorides, anhydrides, esters, and amides. There wasn't an amide on there either, was there? I don't think I had any amides on there.
There was amines, but not amides.
Yeah, we didn't have any amides on that old exam. So, we just covered so many reactions, I can't put everything on there. So, make certain you look through all of them. All of them are fair game. So, good chance I'll have some of those. So we didn't have an amide. We had, we did talk about ways to make nitriles. We had using a primary amide with P2O5, phosphorus pentoxide. We'll make a nitrile. I didn't see one of those on the old exam. So don't forget about that one. So there's several reactions. Boy, we covered a lot in chapter 16 and 17. Huge amount of reactions. And there's just no way I'm going to put them all on the exam. So don't get locked into thinking this is what has to be on here. I keep the same format, but I can put any of the reactions on there. So, I'll have this same format where we've got, some naming. We covered a lot of naming. So any of the naming we've talked about, I will have a naming question on there. I'll have a mechanism question, and then all those reactions, and then I have the synthesis question. So it's the same format, but I'm going to change the reactions up. So any of those that we talked about is fair game. So there's a lot that was not on here. Anybody got any questions, homework or anything? If you don't, then you can leave. That's all I've got. If you got something, stick around and ask. If you got some more questions, I'll be happy to help you.